Welcome. I am Chelzia. I belong to Physical Science Department. In this section, we are going to see a topic heat from 9th standard. In this section, we are introducing the topic and we see meaning, definition, source of heat, effect of heat, transfer of heat, concept of temperature, conclusion and reference. First, all the substances in our surrounding are made up of atom and molecule. These atom and molecule are always at vibration motion. Due to this motion, substance have an energy known as heat energy. If a substance produces a vibration, then it is called as heat energy. What is heat? Heat is a form of energy. It can be transferred from one object to another. See the image. Warmer object transfer heat to colder object. The direction of energy flow is from the substance of higher temperature to the lower temperature. Definition: heat is a form of energy that is transferred between system or sub-object with different temperature. For example, between two temperature, the heat energy is flow. The unit of heat is in SI system joule. These are the sources of heat. First is sun, radiation from the sun, and rubbing hands, firing the woods, and electricity. These are the sources of heat. Examples: the warmth from the sun, a cup of hot tea, baking in an oven. Now we are going to see effects of heat. When a substance is heated, the following things can happen. First is expansion, change in state, change in temperature, chemical changes. There are 4 changes. First, if we heat a substance, the molecule gain energy and vibrate and force other molecule apart. As a result, expansion takes place. See this image. In a railway track during summer season, there is a expansion happen because heat. Next, we are going to see one example. First, we take a metal ring and metal ball. Okay. First we inside the metal ball. If it is cooled, it easily takes place. If we heated ball with non-fitted through, while heated the ball cannot go ahead, because if we heated it can expand. This shows that the heat energy causes expansion in solid. This expansion takes place in solid and gas also, but expansion takes place maximum in gases. Then changes in state. We all know the changes of water is in 3 states: liquid, solid, gas. If heat energy is supplied or take out from a substance, it will undergo a change from one substance to another or one matter to another. One of the following formation may takes place during heat energy: solid to liquid, it is called melting; liquid to gas, it is called vaporization; solid to gas, sublimation; gas to solid, condensation; liquid to solid, freezing; gas to solid, deposition. See this how it's transfer from one to one. First, deposition, melting, vaporization, the reverse process, sublimation, condensation and freezing. Next, change in temperature. When a heat energy is added to a substance, the kinetic energy of its particle increases, and so the particles move at the highest speed. This causes rise in temperature. Then chemical changes. Heat is a form of energy. It plays a major role in chemical changes. For example, when we cook a food, we light the wood and it catch fire and the food particle becomes soft because of the heat energy. These are the chemical changes takes place during heat. If for example, if we heat a little substance or anything, the changes, the appearance and the substance will change. So we call as chemical changes. These are the examples of chemical changes: burning wood, rotting fruit, baking a cake, rusting metal, using a battery, digestion, storing milk, exploding fireworks, cooking eggs, photosynthesis, etc. These are the chemical change while heat is happen. For example, we in a practical, when we apply a heat, then only we find the answer, or otherwise we cannot find it, whether it is a positive or negative, while it is changes or not change the reaction. So heat is important during all the process. Now we move to next part, transfer of heat. Transfer of heat takes place in 3 stages. One is conduction, another is convection, third is radiation. First we see conduction. The process of heat, transfer of heat in solid from a region of higher temperature to a region of lower temperature without any action of movement of molecule is called conduction. There is a no movement in conduction. See this image. Next, what are the things we use daily life by the conduction process? We cook food in vessel made up of metals. When the vessel is heated, heat is transferred from metal to the food. When we iron dresses, heat is transferred from iron to the cloth. Handle of cooking utensils are made up of plastics or wood because they are pure conductors of heat. Convection. Convection is the flow of heat through a fluid from a place of higher temperature to a place of lower temperature. By the movement of fluid itself, there is a movement. Convection in daily life. Formation of a land breeze and sea breeze is due to the convection of air. Wind flow from one region to another region by convection. In hot air balloons, heat is transferred by convection and so the ball rises. In refrigerator, cool air moves towards downwards and replaces the hot air because of convection. Then radiation. Radiation is the flow of heat from one place to another by a means of electromagnetic waves. In radiation, the main point is the electromagnetic waves. Radiation in daily life. Heat energy from the source reaches the earth by radiation. While standing near the fire, we feel the heat which is transferred as a radiation. Black surface absorb heat radiation, so the bottom of the cooking vessels are painted. White color reflect the heat radiation. That is why we are advised to wear white cloth during summer. This is the mode of heat transfer. See this image. While we burn the wood, without the movement, there is a conduction takes place, and then convection with movement, then the radiation because of the electromagnetic waves. Heat and temperature. The heat energy from the stove burns warm the water, but the temperature measure the temperature of the water by using thermometer. Temperature is the degree of hotness or coldness of a body. Unit temperature, SI unit of temperature is Kelvin. For a day-to-day application, Celsius is we used. Temperature is measured within a thermometer. Temperature scale, there are 3 different scales to measure the temperature. One is Fahrenheit, Celsius or centigrade, Kelvin or absolute scale. First we saw Fahrenheit scale. In Fahrenheit scale, 32 Fahrenheit and 212 Fahrenheit are the freezing point and the boiling point respectively. In Fahrenheit scale, there is a pot difference between the interval. There are 180 pots. In Celsius scale, also called as centigrade scale, 0 degree is called as freezing point and 100 degree is called as boiling point. Interval has been divided into 100 pots. Kelvin scale is also known as absolute scale. On the Kelvin scale, 0 K represent the absolute zero, the temperature at which the molecule of the substance have their lowest possible energy. The solid, liquid, gas phase of water can coexist in equilibrium at 273.16 Kelvin. Kelvin is defined as 1 divided by 273.16 of the triple point temperature. These are the formulas how we convert from Celsius to Fahrenheit. We use Fahrenheit is equal to 9 by 5 multiply Celsius plus 32, while Fahrenheit to Celsius, Celsius is equal to 5 by 9 multiply Fahrenheit minus 32. Why converting Celsius to Kelvin? Kelvin is equal to Celsius plus 273. Kelvin to Celsius, Celsius is equal to Kelvin minus 273. These are the temperature scale. In below we saw freezing point of water, above boiling point of the water. Conclusion. Now we conclude this section. In this section we saw the how heat is produced and how heat is transferred. So heat is transferred from hot region to cold region, and there are three forms of transfer: conduction, convection and radiation. Conduction takes place in solid and convection takes place in liquid and gases. Radiation takes place in the form of electromagnetic waves. There are three types of scale of temperature: Fahrenheit scale, Celsius or centigrade scale, Kelvin or absolute scale. These are the reference book, internet resources. So thank you.